Welcome back to the Deep Dive. Today we are diving into deep sea mining.
Yeah, and it is a wild topic today.
It really is. I mean, I just want you to imagine a rock for a second, just sitting in pitch blackness, miles below the surface of the ocean.
Right, where it's just freezing cold.
Exactly, freezing cold. The pressure is completely immense. And yet this seemingly dead piece of stone is like somehow generating its own electricity and breathing pure oxygen into the water around it.
Which just sounds impossible, right? Like something out of a sci-fi movie.
Totally.
Yeah.
But now I want you to imagine a fleet of massive robotic bulldozers. I mean, we're talking machines the size of a house.
Yeah, just massive industrial equipment.
Right, and they're being deployed all the way down to the bottom of the ocean to just vacuum up billions of those exact rocks. And why? To power the battery in your next electric car.
It's crazy. I mean, when you look out at the ocean, you're really only seeing this very thin, sunlit layer on top. But down at the bottom, it's a massive alien world.
And what's happening down there right now could completely rewire the global economy. Could change the energy grid and literally impact the air you breathe every day.
Yeah, the stakes are just incredibly high with this one.
So our mission on this deep dive is to explore that massive, dark underwater frontier. We really need to unpack this huge global debate over whether sending heavy machinery down there is like the ultimate key to a green future.
Or if it's just going to be a devastating environmental disaster. Because, honestly, both sides are yelling pretty loudly right now.
They really are. You've got giant companies promising this green utopia, and then scientists warning about an absolute catastrophe.
And there's huge money attached to this. Trillions of dollars.
Exactly. Which is why we need to establish the rules of the deep dive right up front for you listening. This topic has intense politics and huge money involved, but we are going to strictly stick to the facts.
Right. No taking sides here.
None at all. We have a massive stack of sources, science papers, economic reports, international laws, and we are just going to explore the strongest arguments from the mining companies and the strongest counter-arguments from the scientists.
Just following the evidence to figure out what's actually happening miles underwater.
Right. So, before we can even understand the ocean controversy, we kind of have to look at dry land first, right?
Yeah.
Like, why does everyone suddenly want to go miles underwater?
Well, it all comes down to the big energy transition. The whole world is trying to move away from fossil fuels, like coal and oil.
Because of climate change.
Exactly. We want to use wind and solar power instead. But there's a huge physical problem with that. The wind doesn't always blow, and the sun doesn't always shine.
Right, so you have to store the energy somehow.
Exactly. You need batteries. Millions and millions of batteries for the power grid, and billions of batteries for electric cars.
And building those batteries requires a massive amount of metal, right?
A staggering amount. We're talking highly specific metals. You need copper for the wiring. You need nickel so the battery can hold a lot of energy, so your car can go 300 miles on a charge instead of just 50.
Oh, wow, okay. And what about cobalt? I hear about that one a lot.
Yeah, cobalt is super important because it keeps the battery stable.
Yeah.
It basically stops it from overheating and catching fire when you plug it in to charge.
That seems pretty important.
Yeah.
So how much of these metals do we actually need?
The demand is expected to jump by 500% by the year 2050.
Wait, really? 500%?
Yeah. It's an explosive curve. And the problem is getting those metals from land-based mining is getting harder and way more expensive.
Because we've already dug up all the easy stuff, I guess.
Exactly. We've depleted the easy deposits. Now companies have to dig massive open pit mines, process way more dirt, and use tons of energy just to get a little bit of copper or nickel.
And it's not just expensive. Land mining has a pretty terrible reputation right now.
It really does. The mining companies make a very strong point here. They say, look, when you dig a huge mine for nickel on land, you're often clear-cutting ancient rainforests.
Right, you're destroying habitats.
Yeah, and you're polluting the drinking water that local communities rely on with all this toxic runoff. Plus, the human rights issues are just awful.
Yeah, especially with cobalt, right?
Yeah.
Like in the Democratic Republic of Congo.
Exactly. A huge portion of the world's cobalt comes from there, and there are very well-documented issues with terrible labor practices, incredibly dangerous working conditions, and even child labor.
So the mining executives are basically saying, if you want green energy and electric cars, we have to get the metal from somewhere.
Right. They asked the public, would you rather we keep tearing down rainforests and exploiting people, or should we go to a place where there are no trees and no towns?
Enter the deep ocean.
into the deep ocean. Geologists have actually known for a long time that there's mineral wealth down there. It mostly comes in three different types.
Let's break those down because I know they aren't all the same. First, you have these things that are basically underwater hot springs, right?
Yeah, they're called massive sulfides. They form along volcanic ridges where superheated water blasts out of the ocean floor. It hits the freezing ocean water and instantly turns into these big rock chimneys full of copper and gold.
Okay, that sounds intense. What's the second type?
The second type is this crust that forms on the sides of underwater mountains. Over millions of years, metals in the seawater slowly stick to the rock and form this hard crust that's really rich in cobalt.
But neither of those are the main focus of this new gold rush, right? The grand prize is the third type.
Yes, the absolute grand prize. They are these potato-sized rocks that just sit on the ocean floor.
I love how they basically just look like burnt potatoes or like charcoal briquettes.
Yeah, they don't look impressive at all, but structurally, these rocks are just packed with the exact battery metals the world is starving for: manganese, nickel, copper, and cobalt.
And the best part for the mining companies is you don't even have to dig for them, right?
Exactly. You don't have to blast open a mountain or dig a tunnel. They literally just rest right on top of the soft mud at the bottom of the sea.
It's wild. And the main area everyone is looking at is this one specific huge patch of ocean, right?
Yeah.
Between Hawaii and Mexico.
Yes. It's a massive area, roughly half the size of the entire United States. And the estimates say that this one patch holds about 21 billion tons of these rocks.
21 billion tons. I mean, to put that in perspective for you listening, that is more of these specific battery metals than we have in all the known reserves on dry land combined in just one patch of ocean.
It's a mind-boggling amount of metal. So the mining companies argue that this is a much cleaner way to get what we need.
Right, because you just vacuum them off the seafloor.
Yeah, they claim that if we just extract half the rocks in that specific area, we could power 1 billion electric cars and create a fraction of the carbon pollution of land mining.
So if I'm understanding this right, it's basically like finding $1 trillion piggy bank just lying in a dark, empty desert.
That's a great way to think of it.
You just walk over and pick up the coins. But wait, is it really an empty desert down there?
And that's the thing. For a long time, because it's pitch black, freezing, and under crushing pressure, people assumed it was a complete dead zone. Nothing could possibly live there.
But science tells us we were totally wrong about that, right?
Completely wrong. When scientists finally sent remote-controlled submarines down there with high-definition cameras, the whole empty desert theory just vanished.
It's basically Earth's final frontier. I read that in 2023 alone, they discovered over 5,000 new species in that one ocean patch.
Yeah, over 5,000. And up to 92% of the creatures they find are entirely new to science. We have never seen them before.
The descriptions of these animals are so bizarre and wonderful. Like, there's a thing scientists actually call a gummy squirrel.
Yeah, it's this large, bright yellow, gelatinous creature with a massive tail. It looks completely alien. And there are these vast fields of glass sponges animals with skeletons literally made of natural glass.
Oh, wow, biological glass. That is amazing. And they have cold water corals and weird pale fishes down there, too.
Exactly. But here's the really crucial part about those potato-sized rocks. They aren't just sitting in the habitat. They literally are the habitat.
Wait, how do you mean like the animals live inside them?
Not inside them, on them. The bottom of the ocean there is covered in this incredibly soft, deep mud. So if you're a coral or a sponge and you need a hard surface to anchor yourself to so you don't sink into the muck, those rocks are the only solid ground around.
I see. So if they take the rocks, they're taking the only foundation these creatures have to grow on.
Exactly. The corals grow in the rocks, the sponges grow in the corals, and the little fish hide in the sponges. The rocks are the foundation of the entire neighborhood.
And these rocks don't just pop up overnight, right? They grow incredibly slowly.
Oh, unimaginably slowly. They grow just a few millimeters every million years.
Every million years.
Yeah, it's like a pearl growing in super slow motion. A rock the size of a grapefruit could be tens of millions of years old.
That's staggering. Which brings us to a mind-blowing discovery from the sources that completely flips our understanding of everything. You mentioned it earlier. Dark oxygen.
Yes. This is incredible. So basic biology teaches us that to make oxygen, you need sunlight, right?
Yeah.
Plants do photosynthesis. No light, no oxygen.
Right. That's what we learn in, like, middle school.
But scientists measuring the water down in this pitch black ocean patch noticed oxygen levels were actually spiking. And when they tested the metal rocks, they found the rocks themselves were producing pure oxygen gas.
Wait, so how does a rock breathe without any plants or sunlight?
It acts like a natural battery. Because the rock is made of all these different metals layered together, it holds an electrical charge, about the same charge as an AA battery.
Oh, wow, so it's actually zapping the water.
Basically, yeah. It's a process called electrolysis. The electrical charge splits the surrounding seawater apart and releases the oxygen.
So these rocks that are millions of years old are literally breathing life into the deep sea without a single drop of sunlight.
Exactly. It completely changes how we think life might have even evolved on Earth.
That is so cool. But it also means that if these rocks are breathing life into the deep sea, scooping them up isn't just picking up loose change in a desert.
No, not at all.
It's more like bulldozing a coral reef that takes a million years to grow back.
Mm-hmm.
So what actually happens when a giant mining machine rolls through this fragile environment?
Well, the science outlines 5 specific giant threats to the ocean. Let's walk through the actual mining process.
Okay, let's look at the harms. What's harm number 1?
Harm number 1 is seafloor destruction. The machines they use are basically giant robotic tractors.
Right, the house-sized bulldozers.
Yeah. They drop them down and they literally scrape off the top layers of the ocean floor to grab the rocks.
And what happens to the stuff living there?
It's total destruction. Anything in the path is crushed or vacuumed up, and because things grow so slowly down there, the damage is permanent.
Right, there was a really famous study about this in the sources, wasn't there? Where they checked an old test site.
Yes. Back in the late 80s, scientists dragged a small plow across a test site to see how the ocean would recover. They went back 44 years later to check on it.
44 years later. And what did it look like?
The tractor tracks were still perfectly visible. They looked like they were made yesterday. And the life had not returned. It is essentially permanent damage on a human timescale.
Wow. Okay, so that's the direct destruction. What's harm number 2?
Harm 2 is dust storms of the deep.
Right, because when you drive a massive tractor over fine mud, it kicks up a lot of dirt.
Exactly. But on land, dust settles pretty fast. Underwater, these clouds of ultrafine mud can travel on ocean currents for hundreds of miles.
And I'm guessing that's really bad for the gummy squirrels and the glass sponges.
It's terrible for them. They survive by filtering the water for food. When this massive mud cloud rolls over them, it literally chokes their delicate feeding filters. They suffocate.
That's awful. Okay, so the tractor scrapes the floor, creates a massive dust storm, then it has to suck the rocks up to a ship on the surface, right?
Yeah, right through a huge pipe. And that brings us to harm number 3. The midwater plume.
What exactly is a midwater plume?
Well, when the rocks get to the ship, they're covered in sticky, toxic mud. The ship has to wash them off. But they can't just keep thousands of gallons of toxic mud on the boat.
So they just dump it back in.
Yes, but they dump it right into the middle of the ocean, thousands of feet above where it came from.
Ah, I see. And why is that specific middle zone so important?
Because that middle zone is a vital highway for marine life. It's where massive schools of fish live, including commercial fish, like the tuna we eat.
Wait, really? So they're dumping muddy, toxic wastewater right where our food swims?
Exactly. And the fear is that the toxic metals in the mud will get eaten by small fish, then bigger fish, and eventually make it into the tuna that ends up on our dinner plates.
That is deeply concerning. Okay, what's harm number 4?
Harm 4 is noise and light pollution. Remember, the deep ocean is naturally pitch black and totally silent.
Right, so the animals down there aren't used to huge industrial operations.
Exactly. The mining machines use blinding floodlights so the operators can see, which can literally blind the deep sea creatures. And the noise is even worse.
Because sound travels really far underwater.
Very far. The roaring vibrations of the pumps and tractors introduce massive noise pollution. This is incredibly dangerous for marine mammals, like whales, who use sound to see their environment and talk to each other.
Oh, like echolocation. So the mining noise just drowns out their ability to communicate or find food.
Right, it confuses them and causes chronic stress. Now, the final one, harm number 5, might be the biggest threat to the whole planet.
Let me guess, it has to do with climate change.
Yep. It's messing with the carbon sink. The ocean floor naturally stores massive amounts of carbon that have drifted down over millions of years.
So it's basically locking the carbon away safely in the mud?
Exactly, which helps regulate our global climate. But if you send fleets of massive tractors down there to churn up the mud,
You risk releasing all that stored carbon back into the ocean and maybe the atmosphere.
exactly, it completely messes with the ocean's ability to help fight climate change.
So to summarize all this destruction for the listener, it's like taking a massive leaf blower and a huge fleet of bulldozers into a quiet, dark library that hasn't been disturbed for millions of years.
That is a perfect analogy.
It's not just a little messy, it completely ruins the library for everyone. The books are shredded, the air's full of dust, it's deafening.
Yeah, the ecosystem is shattered.
But wait, I have to play devil's advocate here. Even with all this terrible damage, don't the mining companies say we have to do it to stop climate change? Like, what about the carbon math? If getting metals from the ocean causes less carbon pollution than getting them from land, isn't it worth it?
That is the big question, and it forces us to really look at the climate myth and the missing math, because the mining companies argue that this is the ultimate green solution.
So, is it? When the scientists actually checked the math on the carbon footprint, what did they find?
They found a huge shocker. It turns out whether you get your metals from a forest on land or the bottom of the sea, digging them up isn't actually the biggest source of carbon pollution.
Wait, really? Then what is?
Processing the metals. 70 to 85% of the carbon pollution comes from melting and refining the rocks in massive, super hot furnaces.
Oh, because you have to melt the rock to get the actual battery metal out, and those giant furnaces run on fossil fuel.
Exactly. So if 85% of the pollution comes from the melting process on land, it doesn't magically fix the climate problem just because you pulled the rock out of the ocean instead of a mountain.
Wow, that totally punctures the whole green ocean argument.
It gets worse. The carbon math is highly debated, but one independent study found that deep-sea metals could actually create 28% more carbon pollution than land-based metals.
Wait, 28% more pollution? How is that even possible if the mining companies keep claiming it's so much greener?
Well, this is where we have to talk about misleading studies. The independent researchers found that 2 of the major studies claiming deep-sea mining was great for the climate were actually funded by the deep-sea mining companies themselves.
Of course. An industry investigating itself and finding it did nothing wrong.
Right. And in one of those company-funded studies, the researchers completely left out a huge part of the math to make their numbers look better.
What did they leave out?
Well, these potato rocks are made of a lot of different things, but a huge portion of the rock is a metal called manganese, like up to a quarter of the rock. But processing manganese takes a ton of energy.
So what did the company researchers do?
They just pretended they weren't going to process it. They left 95% of the manganese entirely out of their carbon math.
You're kidding. That's like me saying I baked a completely zero-calorie cake, but I just left the sugar and butter out of my calorie math.
Yeah.
You can't just ignore 95% of the rock.
Exactly. It artificially made the carbon footprint look incredibly low, but in reality, they're absolutely going to process that manganese to sell it.
That is incredibly sneaky. And what about the carbon sink we talked about earlier, the mud being churned up?
The numbers on that are rough. The tractors would disturb about 172.5 tons of stored carbon for every square kilometer they mine every single year.
Okay, and how much carbon does that patch of ocean naturally capture in a year?
Only about 13.9 kilograms.
Tons versus kilograms. That's a massive difference.
Yeah, they are kicking up way more carbon than the ocean can naturally fix.
So if you're listening to this, the big takeaway is that if processing the metals is the real climate problem, then dragging rocks up from the bottom of the ocean doesn't magically fix the green energy dilemma. It just moves the destruction to a new place.
Exactly. It doesn't solve the core issue at all.
Okay, so if the environmental damage is this severe, and the climate math is, frankly, this sketchy,
Yeah.
who is actually in charge of stopping this or giving it a green light?
That leads us to the ocean gold rush and the missing sheriff. Because managing this is a geopolitical nightmare.
Right, because these rocks aren't off the coast of California or Mexico. They're in international waters. Nobody owns them.
Well, actually, international law says they belong to everybody. The United Nations created a rulemaking group back in the 90s to manage the deep sea. It's an international organization headquartered in Jamaica.
Okay, so there is a group in charge. Why is it a nightmare?
Because their job is completely contradictory. They're supposed to organize and promote the mining, but they're also supposed to protect the environment from the mining.
That's impossible. You can't be the promoter and the environmental protector at the same time.
Exactly. And because of this, it's turning into a massive geopolitical gold rush. Countries are scrambling to grab territory before the final rules are even written.
Who are the big players right now? I assume the U.S. is heavily involved.
You'd think so, but the United States is actually in a weird position. The U.S. never fully signed the main international ocean treaty, so they don't actually have a seat at the table with the rulemaking group.
Wait, really? So American companies can't just go mine?
No, American companies are worried they'll face international legal trouble if they just go dig on their own, so they are trying to form alliances with smaller island nations in the Pacific to get legal cover.
Oh, that makes sense. They use the smaller countries as a shield. Who else is grabbing land?
China is a massive player. They currently hold 5 different exploration contracts. They really want to control the future battery market.
But it's not just the big superpowers, right? I read that developing nations are stepping up too.
Yes, and this is a really important shift. For example, the nation of Ghana is getting deeply involved. This brings an African identity to the rulemaking table for the first time. They want to ensure they aren't left out of the economic benefits, like they historically have been with land mining.
So you have all these countries scrambling for contracts, writing the rules as they go. But there has to be some pushback.
Oh, the pushback is massive right now. We currently have 24 countries, major conservation groups, and hundreds of scientists all calling for a pause or a complete ban on deep-sea mining.
They want to stop it before it even starts.
Yes. They are arguing that we simply can't bulldoze an alien world before we even understand how it works.
And I saw there are even conflicts brewing with other ocean users, right? Like people who actually work on the ocean.
Totally. The global fishing industry is furious. Remember the toxic mud dumped in the tuna highway? They are terrified it will ruin global fisheries.
And what about the internet? Didn't I read something about the cable companies?
Yeah, the telecom companies have giant fiber optic internet cables running along the seafloor. They are incredibly worried that giant blind robotic tractors are going to accidentally cut the cables and knock out the global internet.
This whole situation just sounds like a classic Wild West gold rush.
Yeah.
But in a town with no sheriff. Everyone is trying to write the laws while they are already swinging their pickaxes.
That's exactly what it feels like. It's total chaos right now.
So if it's this messy and this dangerous, do we actually need these deep-sea metals right now? Are there smarter ways to power the future without destroying the deep ocean or rainforests?
Yes. And this is the most hopeful part of the research. Experts say we really need to rethink how much metal we actually need. It's a false choice to say we must destroy one ecosystem or another.
Because right now, the math assumes every single person on Earth is going to buy a massive electric SUV with a giant battery, right?
Exactly. But if we invest heavily in public transportation, like electric buses, and design better cities where people can walk or bike, we wouldn't need billions of massive personal car battery.
That makes total sense. Changing how we move changes how much metal we need. What about the metal we already have?
That's the second big solution, a circular economy. Right now, we just throw old electronics in the trash. We need to get much, much better at recycling the metals we already have in our old phones, laptops, and early electric cars.
Because that metal doesn't go bad, right? We just have to pull it out.
Right. The technology is getting so good that we can recover almost all the critical metals from an old battery. If we mandate recycling, we don't need to dig up nearly as many new rocks.
And what about the financial side? Where's the money going?
The financial world is starting to get warning signs. Analysts are saying instead of pouring billions of dollars into super risky, untested deep-sea mining, they should invest that money into cleaning up the land mining we already do.
Making terrestrial mining safer for people and the environment.
Exactly. Make the processing furnaces run on green energy, make the labor safe, invest in protecting the ocean to help fight climate change rather than tearing it up.
It's basically like deciding your house is too messy, so instead of organizing it, you just decide to build a completely new house underwater.
Seriously, that's exactly what it's like.
Maybe we just need to get better at cleaning up and reusing what we have right here on land.
Yeah.
It really puts the whole thing in perspective.
It does. And before we wrap up, I want to leave the listener with one final, super provocative thought from the source material that really stuck with me.
Oh, lay it on me.
We talked about how 90% of the species down there are completely unknown to science, right?
Right. The gummy squirrels and the glass sponges.
Well, it's not just the big animals, it's the tiny stuff. The microbes living on those rocks have evolved in this freezing, toxic, high-pressure world for billions of years. They play these incredibly unique roles in Earth's chemistry.
Okay, so they're totally unique.
Right, and historically, human medicine gets its biggest breakthroughs from weird nature. Think about penicillin or the enzymes we use for global pandemic testing. They come from weird extremophile bacteria.
Oh, wow. I see where you're going with this.
What if, by scraping the ocean floor to build slightly cheaper car batteries, we accidentally wipe out a bizarre, unknown deep-sea microbe that actually held the chemical cure for a major disease?
We would literally never even know what we lost.
Exactly. We are essentially burning down an ancient library just to harvest the metal in the bookshelves before we've even read a single page of the books inside.
Wow, that really hits hard. Burning the ancient library before we even read a single page,
Mhm.
it just shows how incredibly high the stakes are right now.
Yeah, it's a decision that will echo for a very long time.
Well, that gives us all a lot to think about. Thanks for coming along on this deep dive with us. Remember to follow us on your favorite podcast platform, and see you on the next dive.